Greetings, geometry students. I apologize for the delay in getting the notes out to you today. I usually have them going much earlier than this. I thought I had the recording done, but could not seem to find the recording or the file anywhere, so I kind of had to start over. At any rate, I appreciate you finding time to get your notes taken care of. Today we are looking at the converses of the parallel theorems. Please copy down the title, Converses of the Parallel Theorems, as well as our objectives. Our stated objective for today is the student will apply the converses of the angles theorems in order to determine if lines are parallel or not. Now let's take just a quick moment here and refresh our memories on what a converse is. Okay, well, we've seen conditional format plenty of times, the if P then Q. In fact, all of our parallel theorems were written in conditional format when we looked at them earlier. And now we're going to be looking at the converses. And remember, a converse takes your hypothesis and your conclusion and switches them, but it does not move the if and the then, just the hypothesis and the conclusion. Our stated objective, our language objective for the day, is we're going to demonstrate the ability to apply the converses of the angles theorems in order to correctly solve problems that so that lines in diagrams can be parallel. Your essential question for the day is, can I use the converses to work with angles around transversals? Okay, so anytime you need more time to copy something down, always press pause so that you can get your information completed, and then hit play when you're ready to move on. Okay, so let's take a look. Now, up until this point, we have been using the fact that lines have been parallel in order to determine the measures of various types of angles. Okay, for example, we figured out that lines were parallel so that we could say that the corresponding angles were congruent, or alternate interior angles were congruent, or same-side interior angles were supplementary, and so on. Now, we're not going to know if the lines are parallel or not. Okay, so we're going to use the converses of these theorems to decide if lines are in fact parallel or if they are not parallel. Okay, so let's take a look at the four converses. We're going to go through this fairly quickly. They all say the same thing, so you ought to be able to get through your notes pretty quick on this. The first converse that we're looking at is dealing with corresponding angles. The original theorem said if two lines are parallel, then your corresponding angles will be congruent. The converse says if your corresponding angles are congruent, that means your lines are parallel. Okay, we're going to use this diagram over and over again, so you may feel free to copy it one time, and then we will simply apply the new rules to it. Okay, but it's the same diagram we've had over and over again, but I've gone ahead and labeled the two lines that the transversal intersects, and I've labeled them M and N. Okay, now obviously angle 1 and angle 5 are corresponding angles. Angle 2 and angle 6 are corresponding. 3 and 7, 4 and 8, we know all this information already. The converse of this theorem is basically stating if any pair of corresponding angles in your diagram can be proven to be congruent, then line M is parallel to line N. I apologize, I should have little line bars over the top of that M and N right there. Okay, so shame on me, but line M is parallel to line N if we can find any pair of corresponding angles that can be proven to be congruent. Okay, next converse. Okay, this time looking at the alternate interior angles. The original rule said if your lines are parallel, then your alternate interior angles will be congruent. The converse says if your alternate interior angles are in fact congruent, that means your lines must be parallel. Okay, so using the same diagram again, you don't have to copy it down, you've already got it. Okay, So alternate interior angles would be like angle 3 and angle 6, and also angle 4 and angle 5. Hopefully we're doing well on identifying which types of angles are which now. Okay, this converse basically guarantees if any pair of alternate interior angles can be proven to be congruent, then line M is going to be parallel to line N. So if 3 is congruent to 6, or if 4 is congruent to 5, then your two lines must be parallel. All right, third converse. It says, okay, well actually the original rule said if your two lines are parallel, then that means your same side interior angles are going to be supplementary. Okay, well the converse says if your same side interior angles are supplementary, that means your lines are parallel. Okay, also keep in mind, same side interior angles are also sometimes called consecutive interior angles. You need to know all of the terminology for all of these guys. Okay, so let's take a look here. Okay, same diagram again. Obviously, angle 3 and angle 5 are same side interior angles. Same would be true of angle 4 and angle 5, or angle 4 and angle 6. Okay, the converse basically says if we can get any pair of same side interior angles to be supplementary, then our two lines M and N are parallel to each other. Okay, final converse, and then we will look at some examples. Okay, this one says, dealing with the alternate exterior angles, the original rule said if your lines are parallel, then your alternate exterior angles will be congruent. The converse says if your alternate exterior angles are in fact congruent, then that means your lines will be parallel. Okay, same diagram once more. And I bet you can guess what it's going to say. Angle 1 and angle 8 are alternate exterior angles, as are angle 2 and angle 7. Okay, so if you can prove that either set of alternate exterior angles are congruent, then line M is parallel to line N. Okay, so let's take a look at some examples on these. Okay, let's say if we're starting off with a diagram like this. Now, there's two different ways these converses can be used. We can use them to identify whether two lines are parallel or not, and we can also use these rules to determine what a variable would need to be in order to say that two lines are parallel. So we're going to use them both ways. We'll start off with this. We've been provided with a diagram. We have some information provided, and we're being asked, are the two lines parallel? Okay, so let's take a look. Now, last time what we were doing is we would ask ourselves, are the lines parallel, and then what type of angles do we have? Well, now we don't know if the lines are parallel, but the angle types always still apply. Because remember, the angle types don't mean anything about the measurements. It's just how to find stuff in the diagram. Okay, so the first thing we would notice on this one is that these two angles that we are looking at here are not any particular type of angles that we have discussed in this chapter. But as we have discussed here recently, we can manipulate some of this information, move it around the diagram a little bit, and that would allow us to possibly see one of our types of angles show up here in a minute. Okay, so we're going to see if we can rearrange the information to help us out. Okay. Well, one of the ones that I always tend to see in the diagrams is vertical angles. Vertical angles are very easy to move around in a diagram, okay? And we don't have to know if lines are parallel in order to use vertical angles or not. Okay, so I'm going to take this diagram, and what I'm going to do is I'm going to move that 110 degrees, okay, through the intersection, and that would place it where you see it now. Okay, so if that is the case, now we can look at it and go, okay, what kind of angles do we have now? Oh, now we have same side interior angles with this new position of the 110 degrees and the position where the 70 degrees is at. Okay, so now that we have a particular type of angle measurement that we do recognize, we can begin the problem. Okay, so I'm going to change the page. There is the same diagram as we had at the bottom of the previous page. Okay, so if these guys are same side interior angles, then they should be supplementary if these lines want to be parallel to each other. So let's check it out. The question is, 110 plus 70, does that actually equal 180 or not? If it does equal 180, the lines are parallel because the angles are supplementary. If it does not equal 180, then the lines are not parallel because they were not supplementary. But of course, 110 plus 70 is 180. So this is a true statement. That means our lines are parallel. Line A must have been parallel to line B for this property to hold true. Okay, so that's one way that these converses can be used. We can use the information to decide if two lines are parallel or not. Another way that it can be used is more along the lines of this example. Okay, just like yesterday, we have information inside of a diagram, some angles marked and some things provided for us about their measurements, and then we're given an instruction not to verify that the lines are parallel or not, because that's impossible without knowing what X is, but we can be given the instruction, we want line C and line D to become parallel, so there must be a value of X that would let that happen. So discover the value of X that needs to happen in order for these two lines to be parallel. Okay, so first question again is, are these any special kind of angles that we know about? And the answer in this case is yes, these are same side interior angles once again. Okay, so now the question is, what are same side interior angles supposed to do if these lines want to be parallel? Okay, well, the answer to that is those angles need to be supplementary in order for the lines to be parallel. Okay, so just like with the last one, we have these two angle measurements that need to add up to equal 180 degrees. Okay, so there's the equation. It's time to solve it. Okay, we walk through our 5 steps for solving an equation. Okay, first step is to eliminate parentheses. Yes, we have parentheses in the problem, but that is just for the angle markers. There's not any distributive property going on in there, so parentheses is not an issue. Step 2 would be to combine like terms. Okay, we definitely have like terms on the left side of the problem. Okay, we have 5x's and then we have negative 3x's. There's no reason for them to be apart like that, so we're going to combine them. 5x's take away 3x's will be 2x's. We also have 2 constants and negative 6 constants. They do not need to be apart like that, so we will combine them. Positive 2 minus 6 is negative 4. So the next line of our equation says 2x minus 4 equals 180. Okay. Step 3 would tell us to put all of our variables together. Well, the variables are already only in one spot, so that's already good. And step 4 would be to move everything away from the variables. Okay, so that minus 4 does not need to be on the left side. So how do you move a subtract 4? By adding 4. And of course, whatever you do to one side of the problem, you must also do to the other. Okay, so adding 4 to both sides will leave just 2x on the left, and 180 plus 4 is obviously 184. The fifth and final step for solving an equation is to get positive 1 for your coefficient of your variable. Right now we have 2x's, but we only want 1. So if we divide both sides by 2, that would give us an x value of 92. If these two angles want to be parallel, then we're going to have an x value of 92 in order for that to happen. Okay. One final example. Find a value of x so that lines E and F will be parallel. Okay, well, same procedure as before. We need to identify what type of angles we may have in the diagram. If they don't comply to any particular type of angles that we know about, we will move some of this information around until we do find some types of angles that we recognize. But in this case, these are alternate interior angles. Okay, so now we ask ourselves, what should alternate interior angles do in order for these lines to be parallel? The converse tells us alternate interior angles need to be supplementary. I'm sorry, need to be congruent for these two lines to be parallel. So in this case, these two angles are going to be set equal to each other, and then we solve again. Okay, so walking through our 5 steps, eliminate parentheses. Yes, we have parentheses, but that's just because of the angle markers. There's no distributive property or multiplication going on in there, so we don't have to worry about that. Step 2 is to combine like terms. Okay, well, on the left side, 2x and positive 7. Those are not going to combine. They're not like terms. On the right, 4x minus 3. Those are not going to combine. Those are not like terms. Okay, so that takes care of step 2. And then step 3 says to get all of your variables together. Oh yes, we have variables on the left and variables on the right. We do not want them all over the place. We just want them in one place. So we're going to make a decision and send them all to the left or send them all to the right. It does not matter which way you go, just pick a direction and go. I choose to move the 2x's to the right side because I recognize that that will make my x's positive. I like positive numbers. So I'm going to subtract 2x from both sides. That will leave just 7 on the left. 4x's take away 2x's is 2x's, and nothing happened to the minus 3, so there it sits. Step 4 says whichever direction you sent all of your variables, send everything else the other direction. So that minus 3 we just mentioned does not need to be over there on the right. So how do you move a minus 3? By adding 3 to both sides. That will leave you 10 on the left and 2 on the right. And of course, the last step is to have only one x. Right now we have 2 of them, but we don't want 2, we just want 1. So if we divide both sides by 2, that will leave just 5 to equal x. Okay, so you can see this is very similar to the math that we were doing before. It's just a different direction that it's being used in, and that's very similar to the way the converses of many of our theorems are going to work throughout the year. I appreciate you finding time to get your notes taken care of, and I'll see you in class.